Okay, so there's a warm-up in your packet on the first page of today's lesson. We have to match these original graphs with the graph of their derivative. So we can do number one together. If I look at the slopes, or what the derivatives would be for every point, on this piece of my graph, the slopes are always negative, and on this piece, the slopes are always negative. And I have no derivative at 0. So looking over here at my derivative graphs, which graph is always below the x-axis, or always negative? Not that one. Oh, right here it's C. This part's below 0. I have nothing at 0. And then this part's below 0. So if we do the same thing for 2, I'm going to look for my derivative to cross the x-axis on 0. And that happens a few times. There. But let's match our slopes. This slope here will be positive. This slope here will be negative. So which of the derivative graphs, we already used that one, which of the derivative graphs is above the x-axis on the left and below the x-axis on the right? That happens in A, but it also happens in E. But I notice with E, this jump, which means there's no derivative at 0. So, well, here I want it to cross the x-axis at 0, so it has to be A. And then here's my positive, here's my negative. Okay, so you try 3, 4, and 5. We'll pause the video so you can do that. I'm going to start with graph E. Because of this jump, I know there's no derivative at 0. And that happens right here with this sharp point. So that has to be E. Now if I look at 3, I have this maximum, this minimum, and this maximum. Meaning the derivative is 0 at these 3 points. So of my graphs that are left, which one has 3 zeros? And see how these x values correspond to these same x values? You can also look at the slopes. Positive, negative, positive, negative, positive, negative, positive, negative. And this one's B, and that leaves this to be D. Okay, so at the bottom of the page, this is a summary of what we talked about Thursday. So if you weren't here Thursday, pay super close attention, even if you forgot over the long weekend. At some point C in the domain of the function, where the derivative is neither positive or negative, there's two things that can happen. The derivative can be 0, or the derivative can be undefined. If that happens, if the derivative is 0 or the derivative is undefined, that point C is called a critical number. So if I look about that graphically or geometrically on a graph, a critical point happens where the tangent is horizontal, meaning the slope is 0, the derivative is 0, or there's a sharp turn or vertical tangent, meaning the derivative is undefined. So we can practice that concept with this graph. Where is the tangent line horizontal? That's when the derivative is 0. So which of these critical points does that happen at? Happens there, 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 and there. So that's C1, C3, C6, and C7. A vertical tangent, that happens here. That's it, just C2. And then no tangent, that's a sharp point. So that's here at C4 and C5. so find the critical numbers. There are two steps to find critical values. The first is to find the derivative. The second step is to set your derivative equal to 0 and solve for x. You also have to consider where f prime of x is undefined. So this would happen if there's a fraction. You'd be undefined with your denominator equal to 0. We're not going to see this a lot. It's mostly going to be when the first derivative equals 0. Alright, so finding the first derivative, we're going to use our power rule. 5x to the 4th minus 20x to the 3rd plus 15x squared. Then we have to set that equal to 0. And now to solve this, we have to factor. So what is the greatest common factor of these three terms? They share a 5 and they share an x squared. And let's see what's remaining. Here we'll be left with x squared minus 4x plus 3. Well, this trinomial factors again. What multiplies to 3 that adds to negative 4? Let's see, that's negative 3 and negative 1. So now I have to set each factor equal to 0. And solve each factor. So here we get 0, here we get 3, and here we get 1. So these three values are our critical numbers. Now what's really important is the first derivative test. That's what we were working up to. These pictures say the same thing here in words. So if you're more of a visual person, these pictures say these two concepts. Your function, the original function, has a minimum at the critical value if the derivative is negative to the left of that value and positive to the right of it. Meaning we're decreasing and then increasing. You have a maximum at that critical value if your derivative is positive to the left and negative to the right, meaning you're increasing and then decreasing. So that's a maximum. We'll pause the video here so you can copy all of this down, and then we're going to use all of that in our second example. Okay, in your packets, you don't have this chart. Please draw this chart right now so that we can use it for this problem. We'll pause the video so you can draw it. To find the max and min values, we first need to find our critical points, our critical values. So if I find my first derivative, and set it equal to 0, and solve. So let's see, to solve this we have to factor. The greatest common factor is 2x. But then this trinomial factors again. Both have to be positive. So when I solve, we get x is 0 x is negative 1/2, and x is negative 1. And we're going to use this chart to help us figure out where the max and mins are at these three critical values. So I'm going to use these lines here, here, and here, like a number line. So I have to put my critical values in order from least to greatest. So negative 1, negative 1/2, and 0. And I'm going to fill in my chart as an interval, so I'm always going to go from negative infinity, it's the furthest left value, to negative 1. Oops. Then in between here is from negative 1 to negative 1/2. In between here is negative 1/2 to 0. And then out here is 0 to infinity. So now we need to figure out, picking a value, any value you want, in this interval, what the sign of our derivative is, if it's positive or negative. So let's pick negative 2. So when I plug negative 2 into my derivative, I'm going to have a negative times a negative times a negative. So that equals a negative value. So this whole sign of the derivative is negative. If you want to actually calculate it, you can, but we don't need the actual number. We just need the positive or negative sign. So here we pick negative 2. In between this interval, let's pick negative 3/4. So 2 times negative 3/4, that'll be negative. Here, this is going to be negative. And then here, that's going to be positive. So negative times positive is positive. Okay, got to do it again. What's a value between negative 1/2 and 0? Let's do a negative 1/4. That's negative. And then here, let's see, that's going to be negative 1/2 plus 1, so that's going to be positive. And then here, it's going to be positive. That's a negative value. And then last but not least, any number more than 0, let's pick 4. Positive, 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 all positive. So if I think about what all that means, is when your slopes are negative, your original function is decreasing. And when your slopes are positive, your original function is increasing. Slopes are negative, decreasing. Slopes are positive, increasing. So if I think about what that looks like with what we talked about above, decreasing to increasing, this is going to be a minimum value at negative 1. Increasing to decreasing, it's going to be a max at negative 1/2. Decreasing to increasing, that's going to be a minimum at 0. But I still haven't answered the question, what are the max and min values? So for my minimum, that's some y value at x equals negative 1, and some y value at x equals 0. Well, let's start with 0. That's the easiest number. I plug this back into my original to find the minimum value. So 0 plus 0 plus 0 minus 8 is negative 8. Then I need to take the negative 1 and plug it in to the original function. We're also going to get negative 8. To do the same thing for the max, there's some y value at x equals negative 1/2. So when you plug negative 1/2 into the original function, we're actually going to get negative 127/16. Okay. Your homework or your job for the rest of class is to complete the next 4 problems in your packet. These are what the quiz is going to look like tomorrow. I'm going to give you the charts, give you all these blanks to fill in. And we're going to pause the video here for you to try number 1 on your own, and then we'll resume the video and I will have my work and my answers there for you. Okay, finding the derivative. Let's see, that's x squared minus 2x minus 3. So setting that equal to 0, I can factor it, and I get 3 and negative 1 as my critical values. So filling in my chart, these put my x values in numerical order. Write my intervals. And then when I plug in a value, let's see, anything less in between here, let's do negative 2. So picking negative 2, and I plug that in, we're going to get a positive value. Let's pick 0, plugging that in, I'll get negative. Here I'm going to get a positive. So we've got increasing, decreasing, increasing. This actually gives me my answers down here for E and F. Let me fill those in while I'm thinking about it. So we're increasing on this interval, and from 3 to infinity. And then we're decreasing from negative 1 to 3. Okay, let's finish the max and min. If I fill in these values, if I plug 3 into my original function, way back up here into f of x, when I plug in 3, I get negative 6. When we plug in negative 1 to the original function, we get 14/3. So now, thinking about my first derivative test, increasing to decreasing, decreasing to increasing, I have a max here, so 14/3 at x equals negative 1, and here's my minimum, negative 6 at x equals 3. So if I'm going to make my sketch, negative 1, 3, I need to make sure my maximum's at negative 1, my minimum's at negative 3. Could even label these y values now that I have them. So there's just my sketch. Okay, so your job is the remainder of these problems through number 4.